Hi there, I'm Chris Muir with Centennial College's School of Transportation. We're at the Ashtonby campus, and today what we're going to talk about is this right here. This is the replacement for our traditional vacuum booster. Now, where we get into some problems with traditional vacuum boosters is on, of course, our regular turbocharged cars where we get low manifold vacuum, but we can overcome a lot of that stuff with check valves and vacuum pressure sensors. But more and more we're getting into hybrid and electric vehicles. Some hybrid and electric vehicles may not use a brake booster at all. They may use an accumulator inside of the ABS system in order to provide pressurized fluid to help you press the brakes. In other cases, however, there is a brake booster in the vehicle. Now, it can't be power steering driven like Hydro Boost because there is no hydraulic power steering system. Can't be vacuum driven because in a hybrid the engine is off half the time, and in a full electric vehicle there is no engine to produce vacuum. We could use a vacuum pump in order to provide brake assist, but it becomes very inefficient. So this is one of the solutions that we have. This is a electric brake booster. What we see on the outside here is we see some pretty conventional stuff. Here's our input rod. These two studs are where the brake master cylinder would go. And inside the vehicle, very likely this would either mount in this position or inverse, kind of in that position. The top of it, very reminiscent of what we're used to. The bottom of it looks quite a bit differently. We can see we've got some sensor inputs or outputs here, as well as a control module on the base of this electric brake booster. Today what we're going to do is we're going to take it apart and see what's inside, see what makes this thing tick for us. So we're going to start off. I'm going to remove this record tag, as you saw I was starting to do at the very start of the video. We'll just break that off like so, and we will tear right into it. Now, full disclosure, I've already started loosening the bolts on this piece right here. The control board is mated directly to a drive motor. So this is going to be a 12 volt, very likely a DC motor, but I didn't engineer it and they don't really tell you what's going on inside. So we're going to pretend that that's a DC motor. It could be a 12 volt AC motor. And if it is an AC motor, of course, there'd be an inverter on the control board. So let's take that off. We'll just start undoing the bolts here. Now, just a word of caution here. There is a spring inside this pan right here. This spring inside the pan is used to return the piston, much like you would get used to on a conventional brake system. So, just real close. I don't know how good the focus is, but you should be able to see a spring in there. If not, when we get it apart, you'll see the spring. We'll take out a few bolts and get the motor separated from this thing. Now, one of the most popular questions I get asked if we're teaching this in person, can I retrofit this to my hot rod? Now, I'm not here for official advice, but there are other tutorials on the internet about how you can retrofit one of these brake boosters to a older application. So yeah, there's something that, if you're into pilfering junkyard parts, I'm sure you could find one for your application. So, we try. Oh, there we go. So we can see here, we've got a little bit of a gasket there. We've got an electric drive motor right there. We could take apart the circuit board side of it, but I think that would be a bit of a waste of time. I don't know what's going on in there. It's a circuit board. It's got a whole bunch of electronic stuff going on. That's for our advanced electronics courses. So we'll put that off to the side. That's a drive motor, and if we look in there, it mates up to a gear. All right, that's fair enough. Oh, I can feel some tension on the gear. Something's fighting against it. My guess is the big spring inside. So there's a big spring inside there. Oh, and look, we've still got an electrical connector attached. Let's see what's inside this that actually makes the brake booster function. Now, hopefully, these aren't so tight that I can't get them off. Oh, nope, they aren't. I get the pleasure of watching me undo some bolts. Now I can hear this creaking, cracking, so I'd imagine there's going to be some spring tension behind it. I will try my best not to let it go, but we never know. Maybe it won't go. Hold on. We have ways of making it talk. And this all of a sudden feels very reminiscent of when you're taking the top off a strut. How much spring force is in here? We're about to find out. Whoop. Going for a walk. Let me see. We've got all the bolts out of the bottom. So this guy is probably sealed in place. Just on with basic. Let's see, where's my overlaps? Screwdriver time. Alright, we're going to try and do this in a controlled manner. To my snap-on folks, of course this is a pry driver, not a screwdriver. So, warranty still applies. Man, they seal these things up. It's like they don't even want you in here. Here's the old hammer fist here. Oh, try not to take off a finger there. There's quite a bit of gasket material on this, so just try to break that gasket material, so let's go. Oh, we've got it moving. I do believe this won't be worth much. Screwdriver. The screwdriver is still going to be worth lots. Brake booster, however, probably is never going to boost a brake again. There we go. So, as we bring it off, there's that massive return spring I was talking about. And really what you're all here for is the magic inside. Now, inside, here it is. If we press, I'm trying not to break a clip here, so let me just try and undo that. Oh, how does that do up? Oh, we may not get a choice. That may be a permanently attached, not permanently attached fixture. Anyways, let's have a look. Just like a regular brake booster, we've got our adjustable input rod, and when we step on the pedal, whoop, there it is. Told you that wasn't going to stay on there very long. We get this up and down action. This is going to interact with the back of the master cylinder. So you're pressing inside the cab on the brakes, and this guy here is pressing on the back of the master cylinder. Fair enough, those are just manual brakes though. The way this is going to assist you in pressing the brakes is with that electric drive motor. When we get some movement out of that drive motor in the correct direction, what we'll see is it corkscrews to help you push in the brakes. So if you are pressing on the brakes a little bit, just a touch. And it's like, oh, we need to help. What you'll see is it starts to corkscrew in until it too can push up on the brakes. The return is done by that spring. So it's a single directional motor on there, best I can discern. If we keep looking in here, we're going to remove that little piece, and then we are going to undo this. This is going to be your pedal travel sensor in here. And if I can get it off, or when I can get it off here, we are going to see that inside of this, if I can get it off, when I can get it off, I says, there's one broken piece, two broken piece. Again, not being used ever again. Let's see, can we take it off? There we are. This guy here is simply a Hall effect sensor, and it acts against the input rod. So as we get some brake force going into it, we get a deflection inside where it can see how much we're pressing on the brakes. So what happens? These little magnets here, I'll show you. We press on the brakes and the little magnets move up and down inside of this pressure sensor. Remember, the other side of this pressure sensor is attached to the back of your master cylinder. So we press on the brakes and you can see the little magnet there pushes in. The harder I push, the further in it goes. The further in it goes, the more request it makes to the controller here to increase the amount of assist that goes into the brakes. That's all that's inside of one of these electric brake boosters. We got our little Hall effect sensor, or our differential travel sensor, or our input pressure sensor, whatever we want to call it, depending on your manufacturer. We have a double gear reduction from an electric motor in order to increase torque output here. When this corkscrews up, of course, it applies the brakes, and that's it. That's all there is to it. The neat thing about these, we can find them on a whole bunch of different applications. This particular one came from a Honda Accord. The same brake booster is used on many different Teslas. This is simply a Bosh I booster 2. The configuration of the motors on these can differ wildly, but this is all it is. It's an electric motor helping you press down the brake pedal when you need it, because power brakes is a luxury that we've all gotten used to. So for Centennial College, I'm Chris.